We will have a talk from Ananth Packkildurai. Ananth works as a principal data engineer at Zendesk, helps to build the next generation customer analytical platform. So he will talk about the title of his presentation is Back to the Future, Emerging Trends in Data Engineering. So please welcome on stage Ananth Packkildurai.
Right. Hi, everyone. Good morning, good afternoon. It's great to be here on CrunchConf, virtually this time, hopefully in person next time. I'm going to talk about emerging trends in data engineering. Data engineering is a very fascinating field for the last 2-3 years. We've seen like number of development is going on. We've seen like an immense amount of startups is going on. There's various pieces of infrastructure puzzle that we are trying to solve over the period of a time. And this is my observation of what are the things is happening in the data infrastructure and data management space in general. And it's good to look back and summarize overall the trends to see what are the things that are going to move the needle to the next stage for the data engineering. So this talk is essentially a summarization of what are the emerging trends in data engineering from my perspective. So who am I? I'm a principal data engineer at Zendesk. I'm working on the customer data analytical platform for Zendesk to bring data from various Zendesk products, create a customer 360-degree view, and produce real-time analytics on top of it, more of an operational analytics about customer experience data. Previously, I used to work for Slack, where I helped to build the data infrastructure for Slack all the way from ground to up to an IPO thing. I'm also an author of Data Engineering Weekly. It's a weekly data engineering newsletter capturing some of the latest blog posts happening across the world on the data engineering space. It helps me to kind of understood what is the trend is going on, what are the latest development is going on. So if you're interested in this area, please go ahead and subscribe to the newsletter. And you can follow me on Packkildurai at Twitter case. But this talk is neither about Slack or not about Zendesk. It's in general overview of what is the trend is going on in this case. So before we jumping on to seeing the trends, I wanted to take a step back and summarize what are the various stakeholders are in play for the data in the data practitioners world. We have this data engineers, data scientists, business, and ops. All are interlinked to produce or move this data needle to improve the business efficiency over the period of a time. Data engineers' life is all deal about bringing in the data and denormalize or like make it more accessible to rest of the stakeholders, right? It could mean like bringing in controlled, uncontrolled data sets. What I mean by controlled and uncontrolled data sets here, and I take an example of Zendesk. If I wanted to instrument certain business activities or user activities, I do have a full control of that environment where I can go ahead and instrument those tooling, which means that I can control over my schema and to a fair amount of time. And I can try to guarantee some schema modeling upfront. Whereas an uncontrolled data set in most of the cases in the healthcare industry and the finance industry is you get to have a CSV file, you get to have your own data ingested from any other third-party vendors. You don't have any control over the quality or the schema or the correctness of it. So the data engineer's life, it's all about bringing those data, trying to make sense of the data, on top of it, building those compliance requirements like GDPR or PI, and build data infrastructure to do analytics on top of it, either in the batch mode or the real-time mode. There's always a tension between the conformity and the data quality of those infrastructure versus the speed of those infrastructure in this case. And data science team is sit on top of data engineering. What they want is like a fast access to the data. And they wanted to develop the model as quick as possible and to answer some of the business questions, train some models, improve the product experience, verify their machine learning model, run some A/B testing, and all sort of things. The accessibility of the data and the recency of the data and the quality of the data is always pretty important for us. Whereas more accessible data is like more scalable infrastructure, and data engineering is kind of struggling on those. So there is an unbalance between data engineering and data science always. Whereas the business always interact with the analytics team and the data science teams wanted to understand how is my business operate? What is my revenue growth look like? What is my ARR look like? And the last dashboard that I want is yesterday, not today or tomorrow. So the growing need of businesses and most of the modern data companies or modern internet companies now increasingly relying on data to operate their business. So that increases the pressure to time to insight much quicker than what we see in the past. And then there is set up an operations team. And if you notice, even within your infrastructure, the data infrastructure and the tooling is most of the cases in the software companies is completely isolated from what the other infrastructures. What that means is that the security requirements, the compliance requirement, the tooling, the developer tooling that we're doing is going to be completely isolated. The way the data pipeline running a CI/CD pipeline is completely different from what we used to do in Kubernetes. There's a lot of effort is going on to merge to run Apache Spark on Kubernetes, for example, is one effort is going on to kind of merge. But there is always this gap. So eventually the data practitioner's life with all their 4 stakeholders has a different need, and balancing is always a difficult part of the ecosystem. So what is seen like kind of an infinite loop of sadness going across to improve the velocity and time effectiveness and time to insight of the data across all 4 stakeholders in this case. So this talk is essentially take a step back and look what are the trends that are going on and how does it really helping the data practitioner's life. Any technology development that we are doing eventually has to improve the productivity of the humans. So let's take a look at it. The number one trend I see is an increasing awareness and the investments on the data discovery and the metadata management platform in this case. So now why this data discovery metadata management is very important, not only from the architectural perspective, but also from a cultural perspective. What I mean by here is that without a data discovery and a metadata management system, your knowledge about the business and data. So whenever we are creating a new table or a new data assets, we are encapsulating certain business knowledge and derive the data set out of it. It could be an ARR calculation. It could be any number of other business metrics that we are generating is essentially an encapsulation of a business understanding of it. Now, without this discovery metadata management system and documentations around that, the knowledge is often siloed towards a particular human. And imagining a day where a new engineers on board into your infrastructure and trying to understand what does this table look like and what is the meaning of this table, it's always the system entirely skewed depends upon the expert-based opinion. And that is this expert-based data system is also problematic in 2 ways. One, the person who's onboarding has to always look for an expert to understand what is really happening. It introduces a lot of lot of knowledge gap to understand and speed up over the period of a time to create more inclusive environment. And also from an expert perspective, all the request is coming towards an expert, and what eventually they became is kind of a support agent to provide what is the table is meaningful. So you could see even in your workspace, like so many Slack channels and Slack chat is going on and on. Like hey, what does this table means? How can I query this information? Where can I get this information around there? So the most of the valuable time that you have that expert is going to be spent on question and answering rather than meaningfully developing a value to multiply the impact of the data in this case. So data discovery and metadata management is absolutely crucial, not only from a data management perspective, but also from a cultural aspect of it as an effective use and then drive towards a mission for data-driven culture across the company. So we have seen a number of companies now coming across in this space. We've seen Amundsen open source by Lyft, Marcus, again, like running a open lineage projects to understand what is a lineage standards over the period of time. We've seen DataHub has a pretty good scalable solution, more of an event-driven model approach to that. We've seen a lot of tractions and around the investment of these tools over the period of a time. So this is certainly an exciting space to watch and to adopt. And I always tell, if I had to start a new data warehouse system from the ground, I would always start with the data lineage solutions in place that helps to kind of further reduce the complication to manage GDPR compliance and PII compliance, accessing the data assets and managing the data assets over the period of a time. Because once we make it as a self-serve data sets, the growth going to be an exponential, and it's very important to track of those tools to understand what is really going on in this case. So if you don't have a data discovery system in your infrastructure, it's a high time to invest and start looking around to understand how can we incorporate and how can we incorporate this tool into your workflow where someone asking like, hey, where does this table look like? How can we integrate that workflow into the data discovery system in this case? The second trend I'm seeing, data mesh and domain ownership. There's a lot of this back and forth discussion is going around. What is really data mesh means? What that means to, what is a domain driven ownership is mean to the data engineering ecosystem? Does it make sense? It doesn't make sense. Where is the gap? Is it way ahead of our time? But it is a great discussions all around the place. I can see a simple analogy why this is important is that this is the current sad state of the data engineering world, right? Imagine you are writing a dictionary with only the words and no meaning for it. And on top of it, you just shuffle the words randomly and publish the dictionary without any index for it. And you hire high-paid data engineers and data analysts to decode the dictionary. This is exactly the sad state of the data dictionary for the data engineering world right now. Without a meaningful data discovery engine, without meaningful data lineage system, we have no understanding what is this table going to look like. And it's always fall back to the expert opinion on this case. And what is this data mesh essentially challenging? If you step back and see the traditional microservices model, the producer of the microservices own the microservices. They own the quality, delivery guarantee, and any other insight that we wanted to do that in this case. But in the data ecosystems, the producers, often the feature team, which responsible for instrumenting the data and send the data back to the data warehouse system, or pulling the data from any other ecosystems, right? And or in case of like a business analytic cases like Salesforce or any other insight, there's no control over who deleting the field and who's not deleting the field, how the system is going to impact any changes on those systems when we are ingesting back to the data warehouse. Is it a backward compatible? It's not backward compatible. What does it really mean? So the domain understanding is always isolated with the feature engineering team, whereas the data engineering team has isolated with this domain knowledge. Historically, how we are trying to solve this problem with the way of embedded data engineering, right? There will be a data engineering folks kind of embedded into individual team, and trying to understand the domain, trying to understand what are the product features moving in, trying to instrument those data back to the data warehouse system, and then produce a data aggregation on those. So any data products that we are going to develop on top of the data that we are producing, there's always like a back and forth conversation to kind of understood what is this domain means, what is this particular field means when the producer perspective, oh, okay, what is the support ID means? What is this user ID means? Oh, we have this 3 different user ID. What does this user ID mean in your ecosystem, in your domain versus the other domain's user ID? So it's very common cases across having those human to human communications that further delay the product delivery and the future delivery in this case, right? So the domain data mesh is kind of proposing an approach is the domain owners take control of the data and having more ownership to produce insights out of it. The thing is to wait and see, like, is that the tooling is available, ready for us? And this is something, a very fascinating field. I could expect like further development happening on the data side. One of the stopgap I see right now, which is at least in my opinion, is not very clear, is data is inherently social in nature. How those different domains going to interact with each other, how we are going to avoid a situation where we are not going to create multiple user IDs or multiple agent IDs or multiple definitions of an IDs that preventing us to connect each data set together. And historically, we solved this problem by MDM, right? We have this master data management system focusing on this golden data, trying to create this golden data sets to have this conformed schema. But at the velocity the business is moving and the insight that we wanted to have, that it's very, very time consuming to wait for a conformed dimensions across the board. So how does this tooling going to help us is one of the interesting challenge. I will see like more and more development and investment going on in this particular field here. So the theme here with both the data discovery and the data mesh is that catalog the mesh. The moment the goal of a data engineering team is to produce, to be an advisory for a data-driven culture and making more self-serve analytics. But the moment we go to a self-serve analytics, there is also an uncontrolled creation of a data asset. How do we manage the data asset? How do we make sure that we can manage the full life cycle of the data assets? So catalog the mesh is, if one takeaway that I can give from the talk, is always focus on cataloging the data assets, help you to manage your data asset lifecycle. The third trend I'm going to talk about is around data observability. One of the blog posts like Microsoft recently published, a poor data quality is costing more than $3.1 trillion in US economy alone, which is like a 16.5% of GDP of US, which is pretty large. So data quality is a pretty big aspect. Like the cost to repair the data quality is also pretty high. So just to give an example of why this data quality is a little complicated and why the cost is pretty high here. If you compare a traditional request response based microservices, the producer of the microservice pretty much know what is the data they're going to emit, what is the contract between the consumer and the producer. It could be a gRPC interface, it could be some kind of a protobuf, an Avro, or thrift, or a JSON, some kind of an interchange format is well defined and well understood. And we build those integration testing, CI/CD pipeline and smoke test, and everything is kind of well aligned. And the producer, the way see the data is going to be the same as the consumer going to see the data. Whereas in the data pipeline, it's particularly very challenging is the producer of the data is not necessarily the way the producer of the data going to see the data is not necessarily the same as the consumer going to see the data. For example, a producer is producing, take an example of an ARR table, like, it's calculating annual recurring revenue, and that has like multiple dimensions associated with that, and then also have a multiple metrics associated with that. And there might be some downstream consumer trying to create a machine learning model or a predictive analytics solution to understand what is our growth trajectory look like, what is our revenue trajectory look like. And that consumer will have a certain expectation, okay, this particular metrics will always, an assumption like MRR will always go up. That could be an assumption they can make and then train the model based on that. But the producer may not aware of it, and they don't really validate that particular business logic or the quality criteria while producing the data sets. So there's a huge gap the way both stakeholders looking at the data. And when we detect the data quality issue, it could be a one stream down the line, or it could be 10 stream down the line. And when we detect the issue, again, it is very, very costly to build back, backfilling the whole data back again, trying to recover the assets, and debuggability and traceability of those data pipeline is very, very challenging in this case. So that is a challenge with the data observability and data quality, and why it is very costly for us to do. I often used to joke like the whole Wall Street is believing on some untested SQL data pipeline to trust the numbers over the period of a time. And so our whole economy is running on untested SQLs. So data observability is one of the largest trend that we see. We've seen like growing number of startups coming on, trying to understand and trying to resolve this issue over the period of year. We've seen some of the great tooling from DBT has a good integration of model and model validation as a good approach of approaching of data transformation. And we've seen specialized data quality tools like Great Expectations and DQ. And we have seen growing number of integration with the orchestration engines like Airflow, Daxters, and Prefect in this case, right? So this is going to be a very interesting space to watch. And from the architectural perspective, at what point that we are going to instrument the data quality, how does the producer and consumer going to interact with each other, and what is the trade-off between the recency of the data versus the conformity or the quality of the data. So the more and more data quality check that we are running, that means that we are delaying the data pipeline. So we are compromising on the recency on the thing. So the correctness and the recency is always having a trade-off. So this is something, there's a large gap still to understand an effective tool to not only giving us the data quality checking, but also balancing out this trade-off and to effectively running the whole data pipeline workflow. So this is one of the interesting phase to watch and to grow over the period in the coming years. Case. The fourth trend, obviously, I'm talking about data lakehouses, and data lakehouse already started its adoption, if not already. We have seen many bigger internet companies like Uber, Netflix, and Adobe talked about their successful adoption of data lakehouses. So why this is very important is the whole big data processing ecosystem came a very long way, right? When you have 2008, 2009-ish, if you wanted to build the data analytical solution and trying to do the large scale data processing, you had to write your own custom MapReduce job and run this giant job into a monolithic Yarn cluster, and you are focusing more on fine tuning this and trying to understand. There's like a way, the cost to market, cost to get the solution on board and productionize that workload, and to create the business value out of it, that's a path is pretty high. But what those object storage is actually enabled us is we can now store the data at whatever the scale that we want with a minimal tension or minimal workaround to improve minimal workaround for us to kind of focusing on the scalability and the infrastructure aspect of it is that. But that also brings a challenge. We cannot just throw anything onto the object storage and trying to access it. The flexibility and the efficiency of the access is always a challenging. So the data lakehouse tooling, essentially what it is providing is a integrated support for structured information storage, integrated access patterns like incremental accessing. You know, there's an incremental API access is already available, kind of solved in one way rather than you are trying to build the snapshot over and over and again. So these are the interesting development happen. We still have all the flexibility of storing the data in S3. On top of it, now we have this incremental processing, we have the structured storage, and there are pretty good metadata layer on top of it for us to do more data processing in much more efficiency. So the moment we entered into this structured data processing with an incremental view, it also enabled a SQL analytics on top of it. So we can move away from writing a complicated Spark job or a MapReduce job to a more simplified SQL workload in our ecosystems right now. So some of the tools are already in place is Apache Iceberg, Delta Lake, Apache Hudi. The incremental data processing is being supported in one way or other in all kind of system. They all come with a different flavor and different ecosystem. So if you are using S3 or any cloud storages as your data warehouse, and if you might still use Parquet and other aspects of that, Parquet or any other columnar storage, I highly recommend to take a look at this data lakehouse models. It's providing a pretty robust architectures on top of whatever we already knows that create a lot of flexibility for us to build a high scale data warehouse system over the period of a time. The fifth trend I see, which is slightly kind of deviating from the lakehouse architecture and the development is going on, is a growing number of modern data stacks. As I mentioned, we came a long way from the Hadoop world, from running a large monolithic application to all the way from the modern data stacks. Redshift being introduced in 2012. From the days of Redshift, we've seen growing number of data storages, cloud data warehouses is emerging. We've seen successful IPO from Snowflake, completely a cloud data warehouse solutions, trying to bridge the gap of analytical space. So with the Hadoop world from all the way to Snowflake IPO, I think we came to a full circle to kind of enable SQL-based analytics on top of our data warehouse ecosystems. So what that mean for those cloud data warehouse? There are two important trends happening or happened the moment the cloud data warehouses started to flourish. One is that there is a growing need. How do we ingest the data into the cloud data warehouses? How do we do the data transformation on top of the cloud data warehouses? And how do we get the BI intelligence on top of it? That's a completely different stack from how do we bring the data to a Hadoop world or a HDFS world and all those things. So we are seeing like multiple startups, SaaS products coming on to tackle the data ETL problem, transformation on top of the cloud data warehouse. And we've seen BI tools also build it on top of it to kind of support the cloud data warehouses like Snowflake, Redshift, and BigQuery in this case. That's one bigger ecosystem that in the cloud data warehouse enabled those ecosystems to build on top of it. The second trend also that enabled this whole data ecosystem, the modern data stack, is that the companies are now increasingly relying on SaaS applications to run and operate their businesses. If I had to start a new company or a new retail shop, I could create a shop in my Shopify, and I wanted to provide a customer experience solution. I can provision a Zendesk license for that to do that. And if I wanted to manage a customer relationship management, I can buy a Salesforce account for that. So various business activities now happening across the SaaS products. And there is a growing need for the modern data engineering team is to bring those data to one point and to understand what does the business operations look like and how can we improve the business velocity over the period of a time. So the growth of the modern cloud data warehouses, the increasing the dependency on the SaaS application for the business operations, and the whole ecosystems on top of it that essentially kind of born this modern data stacks. So that's going to be a trend over the period of a time. And I'm pretty sure like in all your companies, you would have adopted some part of a component that we are talking about here. We're seeing like in extraction and load, some tools like Arbide, Fivetran, and RotaStack. Data transformation, we've seen dbt and Dataform is coming along. And data warehouses, we've seen BigQuery, Redshift, Snowflake, and extra is coming on in this case. And data governance, we see Data, Schema, Athlon, all those companies are building on top of either an open source solution or a proprietary solution, has a well-defined integration with those data transformation layer, data extraction layer, and data warehouse. So these integrations across the vendors is also going to be an interesting challenge to see that. BI tooling like Looker and more and Metabase is coming along. Right? So there are two challenges which I believe in 2022 or moving on, we'll be focusing on solving this. Number one is that there are a lot of specialized SaaS products trying to solve that whole data pipeline problem. We've seen a tool for extraction, tool for data transformation, tool for data governance and BI tools. Every tool is providing an isolated workflow, and how does it going to unify and give one single user experience? How does the workflow going to look like? Will there be a consolidation of the workflow, or will be the workflow will be still isolated? And as an engineer that we have data engineer team, now the job is not only producing the data set, also to integrate those tooling and provide one integrated work experience, a workflow management system here. So that's one of the interesting challenge to watch. The second challenge, which most of the companies now started to speak a lot, is about the cost management. It's very good to have those modern data stack to quickly start and then bootstrap your business and up and running. As the business grows or over the period of a time, you will create an increasing cost awareness solutions. And all those SaaS products has some kind of a pricing model associated in one way or other in this case. So how does the cost, like, will there be a coherent cost model management across the data warehouse systems for the modern data stacks? And how does the workflow going to be look like? I think these two bigger development, I would see like more and more abstract startups coming on top of it, either from internally from some companies or external vendors in these solutions. The sixth trend I'm going to talk about is the industrialized YAML, right? So we've seen growing number of, similar to machine learning, similar to Hadoop and the whole ecosystem, machine learning also kind of go through its own maturity model over the period of time. We've seen the need for hiring more specialized engineers to build this ML model now kind of more commoditized and put it into the path of an ML workflow system here. We've seen a lot of improvement on development like trend model that you can train for one business use cases and you can share across the company. So it's like kind of a marketplace for the model. It's one of the interesting aspects that to watch on that. How does it going to grow? And we've seen growing number of investments from the companies and also from the commercial vendors around what it mean to have a feature storage and what are the capabilities that we require to have a feature storage, A/B testing platform on top of those machine learning model deployments, and the whole model management ecosystem. So we've seen like more robust tooling is available in commercially. And also from an open source, which in like 4 or 5 years been isolated to only smaller companies access in this case. So this is one of the interesting space to watch on the industrialized YAML, how that's going to commoditize our feature development and in terms of the data engineering aspect of it. One of the other important trend on the industrialized YAML is that, as I mentioned before, there is a growing number of SaaS products providing a vertical business process solutions. For an example, Zendesk is providing a customer experience solution. and Salesforce might provide a customer relationship management platform, and Shopify might provide shopper experience online and offline in this case. So as a business, these companies, the vertical solutions companies, have much more equipped to use the machine learning models to provide and measure what is your customer experience going to look like, rather than you hire and develop those machine learning team to understand what is my customer experience going to be look like. So that is why we see the trend where from the days of ingesting the data into the data warehouse from this SaaS application, we have this ETL solution. We also seeing the trend of reverse ETL. How do I feed back the data from our data warehouse back to this vertical solution? So data sharing and industrialized YAML and shareable model is going to shape how efficiently the industrialized YAML is going to happen over the period of time. So you've seen emergence of TensorFlow, PyTorch getting widely adopted. I've seen like the growth of transformer neural network, a trunk model talked about, the emerging of TPU, where the specialized hardware to run those machine learning and AI models much more faster and efficient in this case. Right? So this is an interesting development, and particularly from a data engineering perspective, from the integration perspective, how far it goes, not only integrating the data, but also integrating the metrics and the model that computed across different ecosystem and controlled and uncontrolled ecosystem and provide a one coherent analytical solution is going to be a trend in coming years. The last one I wanted to touch base is on diversity, privacy, AI ethics in this case, right? So we all talked about how those SaaS applications is coming along, the cloud data warehouses, and then there's a different tooling for us to do the data ingress and moving the data across the ecosystem. It is all great. There is a lot of effort to make sure the free flowing of the data across the pipeline, but that also create a lot of challenges on diversity, privacy, and AI ethics in this case, right? So if you're developing a machine learning model in your company, how do we make sure that that model is adhered to an AI ethics? How do I make sure that from a data engineering perspective, how do I restrict certain fields to be accessible by the machine learning model to be built on top of it and create prediction on top of it, like where I live, what is my age, and what is my race and ethnicity. It's all plays an important role to create a bias when you are creating this machine learning model. How do I, from a data engineering perspective, and as a provider of the data across the company, what is the responsibility of the data engineering team, and how can we systematically going to create tool to enable or prevent this kind of bias in the machine learning model development over the period of time? That's going to be an interesting challenge here. And I think that is why it's like, there's another bigger challenge is that the growing amount of SaaS applications are coming along. And particularly data lineage is an important aspect to solve this problem, because we need to track what are the data, what are the PI information, how it is getting transferred, which system is using it, which consumer is using that. And data lineage is a key aspect of to create that kind of an experience. Now, historically, we've seen data lineage as a tool to identify or track lineage within the data warehouse system. But the modern data stacks enabling the data is not only flowing into the data warehouse, now the data is flowing out of the data warehouse. We are increasingly feeding the data back to those SaaS applications. Now, how do we make sure that we track what information goes away there? How does this model is performing? If there is a bias in those SaaS application model, who is ultimately responsible for that? And what does that mean for building a data engineering ethics within your company is also an interesting questions, and a lot of tooling requires to develop on that. We've seen a lot of development on this space already. We've seen explainable AI, there's a large effort goes on there. We've seen a lot of model trying to build on privacy preserve modeling and trying to detect the AI model bias, but it's still largely in the research space, or only few companies are trying to do that. and there is always the same challenge, the correctness and the velocity of the business rate. And I hope there'll be more investment on this particular field to understand, to potentially prevent those bias over the time. So just to summarize, to have those trends from data discovery, metadata management, data lineage to diversity, privacy, ethics, everything is interrelated and interconnected as we move along as a coherent day in the data engineering space. What does it mean for the domain ownership for us, and observability reasons, the tension between the recency and the data correctness, and the balance between adopting data lakehouse versus the modern data stacks, when to adopt on those things. And as we move, as the system scale, is it make sense to fall back to the object storage and adopt data lakehouse, or it's how it is going to go hand in hand in these cases. So these are the interesting trends, and that going to potentially shape the future of data architectures over the period of a time. So that, thank you so much for listening, and happy to take any questions.
Thank you very much, Ananth. So let's see, we have still a few minutes for questions. Okay. We have a few questions actually, right now 3 of them. So if you still have questions, then please add it to the Q&A section. The first question is there a difference on data engineer data quality and data sciences data quality? Data engineers need to implement those two, I suppose. How do I get the info?
Right. So I think it's a very good question. I see both the same cases, the data quality essentially trying to measure what is the really data quality means. Like we were having a set of rule, a definite bounded rules, and then we are trying to validate whether this particular data set or this particular field is adhered to this particular rule. So it is across the domain, is the same for data science or data engineering aspect of it is that. So the way I would look at it is like, how can we systematically make this data quality frameworks available for the various stakeholders? We don't need to kind of implement over and over again, but how can we build those framework embedded into your data processing? Let's say a classic example is that in Airflow, that's some of the common pattern I've seen. If you are producing a production quality data set, like let's say you are producing an ARR, it's a pretty important number to have the company metrics going around, all the different executives to the Wall Street. So if you are pushing any upstream pipeline or that is dependent upon this ARR, there is a systematic way you can say, like, okay, you are now an upstream dependency of an important pipeline. Do we have a data quality framework in place? Like, do you have a data quality check in place? Then only you will enable this new DAC alteration or any new data set pipeline getting into this to be merged and deployed over the period of a time. So instead of focusing on one data sets, how can we enable, like, how can we systematically prevent these bad actors coming into this play, and even the changes happening that, how can we make sure that this system has a set of data quality standards that will not impact any of our upstream, any of our downstream systems over the period of time? I think that would be the most appropriate solution as a data engineer, rather than going after and trying to, either do a manual testing or I'll have testing to understand data quality of each and every data sets in this case. The framework like this is going to help both the parties, both the data scientists and the data engineering team. So I see the problem is the same, and I see the way to solve is an systematic approach to enforce the standard rather than ad hoc based solutions in this case.
Very much. We still have some questions. So the next one, what is deciding the data quality? Can you give some example of common metrics?
Right. So data quality comes on a multiple form, right? And it is always from the perspective of the business. Very standard data quality check is that like a particular field is a mandatory. So there is a non-null check these are like a basic data sanity check. The data has to not be null. If it is an email, it has to be an email format. If it is a phone number, it is added to the phone number format. If it is an integer or long, it is an integer or long in this case, right? These are the very basic first set of data sanitation check. And the second set of thing is, this is the data check. Then we are moving towards like a business rule check, right? For example, the business rule check is bounded to your own domain. To understand that, for an example of a column that has all the United States, the number of distinct counts should be 50, and you cannot have more number of states than what is supposed to be there. And if you don't have that, then that's a data quality issue right there, right? So your insight might go wrong in these cases. And so those business rules is bounded to the way the business look at the data set, and it's bounded to a domain understanding over the period of a time. So the data quality rule from a data engineering perspective, the very basic data quality check that you can do is how those number format is adhered to whatever the definition of the column, and how those historical trend analysis over the period of a time. Like, let's say we are producing a data set today which has 100 rows, but yesterday it had like maybe 1 million rows. So which means there is something wrong, even though job is running fine, but there is something wrong with this pipeline to understand that. So the first line of defense of the data quality is always like understanding the trend and trying to see the anomaly, and also the basic sanitation check to adhere to the standard of the data definitions. And then the third step, essentially approach from the business perspective, what is the contract between this and this field? And it could be a range. Let's say a number could be 1 to 10, or states has to be 1 to 50, and so on. So, right. So these are the different layers I see the data quality steps going on.
Thank you very much. The next question is quite short. Tips for data lineage tool.
I'm sorry?
Tip for data lineage tool.
Data lineage tool, pitch for data lineage tool.
Lineage tool, yeah.
Is there a recommendation for a data lineage tool?
That's the whole question. Do you have any tips for that?
I don't know. I think it depends upon the architecture. Like, my talk is always very neutral about these tools. It all depends upon what works for you. What is the ecosystem going to look like? So one important factor I would add when you are choosing the data lineage, right? What I've seen over the period of a time, the data lineage is always an afterthought. If you're taking an example of a startup that growing number of businesses, the initial focus will not even in the data engineering space. They will be always wanted to fulfill the business transaction. Let's say a mobile app trying to have the mobile banking app. Their focus is to kind of, okay, how can we move the money across, and then make sure that a transaction happen from the user's perspective. So that will be the first focus of any business. Once that goal is accomplished, then only they'll be focusing on, okay, how I'm going to grow the business now. And that is where the data engineering or data analytics comes into the picture, and trying to instrument whatever the code is already there and trying to bring the data back to build some analytics on top of it. And so when we hire the data team itself, there is a growing need, a growing demand. Hey, I want this insight quickly. So any new data engineering team will not focus on the data lineage tool at all. And it will be always an afterthought as we grow and select, okay, now we have more number of tables. We need to figure it out, some kind of a data lineage tool for us to do that. And I have seen the same case for 99.9% of the companies. So one of the important aspect of is that to understand, to look for the data lineage tool, what is an architectural pattern that enable for you to quickly get to the lineage space. Is there can we pull all the data into the data lineage, how can we have you, by this time you're integrating the data lineage tool, you might have already have the data orchestration engines already in place. You will have your cloud data warehouse already in place. So what is the tool that has a quicker integration into your existing workflow and creating this value immediately? I think the way to look at it is like, from an architectural perspective, how efficiently you can integrate the system and produce the value. So that would be my recommendation. So to way validating data lineage tool, but I can't unfortunately name anyone to do that.
Thank you. Yeah, just to have a summary that we have still 5 questions at the moment. It might be more, and we have about 5 to 8 minutes for them. So let's see how many we can steal. The next one, what is your favorite tool for data engineering? What you recommend? Would you recommend one which is easy to learn for beginners?
I would look in, that's a very good question. So if I had to say that what is a one tool that I can learn, I wouldn't not recommend any framework, but I would say learn SQL. Right? SQL is an ultimate abstraction for data processing, data engineering in the whole. And it's so many people in the past trying to create another abstraction and not to use SQL, the various flaws and for SQL and against SQLs all happened. But I feel like SQL, if you call it as a tool, is a very important aspect of it. So instead of focusing on the frameworks, focus on the fundamentals. SQL and Python as a beginner can take you a long way in the data engineering space. The tools will come and go. The tools lifecycle changes. Even within last 5-10 years, we've seen, back in the days when I started data engineering, it's all about learning MapReduce and Hadoop and understanding the MapReduce algorithm. How do you model the graph analytics on top of this MapReduce algorithm? But that is no longer the case. We're no longer using that. And it's much more commoditized, much more simplified over a period of a time. So always focus on the basic. SQL and Python would be my recommendation.
Thank you, Ananth. Next question. Do you think data engineering job will be fully automated in future?
I think it's a very interesting question. Like, can robots automate the human? The short answer is like, I don't think so. I don't think it could be automated, but that is what we deserve, right? As a software engineer or data engineer, we always try to automate our work to outperform ourselves or outsmart ourselves. And we will be seeing more and more abstraction to simplify our work, to understand, simplify our workflow. But that doesn't mean it's going to eliminate data engineer as a whole. A simple example I mentioned, right? The data quality alone is 16.5% of a GDP cost of an US economy alone. And how are you going to solve this problem? Itself is like a huge challenge for the decades to solve. And as we build more and more abstraction, we will also create more and more problems. So I don't think the job is not in jeopardy or anything. Like, we will automate, and that is an example that we've seen in the modern data stacks also, right? We have these specialized applications now coming in to solve the data extraction, ingesting the data into cloud data warehouse and easy to extract insight out of it. But what it is bringing is that a diverse workflow, and how do we integrate this diverse workflow to manage, move the business needle, and just growing number of vertical SaaS applications coming in. How do we integrate? What is the data sharing means for us to do that? So as we abstracted, we will be seeing more and more problem. And then we will try to abstract it over the period of a time. And then we will go back and reverse and then started to build from the scratch. The same strategies happened last 20 years. If you noticed, we've gone from like Vertica and Oracle based SQL solution, and we gone to Hadoop and MapReduce world, and then we are moving back again to Snowflake and the and Redshift model here. The database is the same, only the place where it is running is different now. So I think the trend will go on.
Thank you, Anand. We still have 2 questions and only about 3-4 minutes, so try to be short, and then we can do both. So the first
Awesome.
one is data quality alerting is filtering. Should we separate them on data flow?
Um, the short answer, I would say like no, because data quality is also a part of a data set lifecycle. So uh, let's say you are excluding the data quality check and alerting from data set creation. You are creating a new table without any data quality check, and you are running after the fact data quality check. And by the time your downstream pipeline started to processing that, and if you are detecting that data quality problem, now where is the circuit breaker that we wanted to do that? And by the time we detect the data quality problem, and the cost associated to backfill those data set is not cheaper, right? You have to have a computing cost, another aspect of this, right? So uh, to answer your, to the short answer is like, it can be separated. It depends upon what is the data validation that you wanted to do that. Is it okay to run a data quality check after the fact? Then please do that. It is typically like, imagine, right, you are writing a symbol method, method to calculate A plus B. So the first step you will do, like, check whether A and B is an integer or not. That's a precondition check. And then you are running your business logic, and then run a post condition that say like, is your result is correct or not, asserting is true or not. It's the same mechanism when you are building a data assets. So if you can do an after fact data quality check and the cost of backfilling is not going to be huge, it's okay to do an after the fact data quality check. But if the cost is going to be pretty high, and it makes sense to have it as part of the life cycle of the data assets.
Thank you. And last question, really shortly. There is there are ongoing challenges about data privacy. I don't
Mhm.
know if you are familiar with federated learning, which could solve this problem. If yes, what is your opinion about it?
I don't aware of those things. I will be happy to kind of look around to understand what does it mean to do that. And that seems to be very good news. I can definitely look it up.
Okay, thank you very much for your time, Ananth, and I congratulate you because I think your presentation got one of the most comments or questions after, so it was really interesting and engaging the audience. So thank you very much.